Good afternoon, everyone, and welcome to the Slant 3D podcast, the show about 3D printing and our place inside the industry. Today, we're going to talk about 3D printed chicken in Campbell's cans, and as well as some 3D printed swimming legs, and talking about a small patent dispute about an open source project that wasn't open source but now is, about bed swapping. And of course, we'll finish it all off with the interview of the week with Pawel Slusarczyk, which I am very excited about, and having some discussions around teleport and portals, which is going to be fairly significant for 3D model designers, I think. But before all that, let's go ahead and pay the bills. This episode is brought to you by Teleport. If you just came out of the Black Friday season and you need to offload a little bit of capacity because you want to spend some time with your family, you probably ought to check out Teleport to help fulfill some of those orders. It's like having 1,000 3D printers on tap. It takes about 20 minutes. You plug it into your Etsy store, and then whenever you get an order, that item will be printed and shipped straight to your customer for you. This lets you spend time with the family, enjoying the turkey, watching the lights twinkle, without having to worry about if the beds need changed out, if you need to change the filament, if the boxes have been packed, and if Etsy needs you to answer the message in the next 6 hours before they cancel your store. Teleport can relieve all of that stress by making sure that the printing, packing, and shipping are taken care of for you so that you can focus on taking care of your customers and creating more awesome products rather than dealing with all the logistics of how those products get delivered. So check out Teleport today over at slantpod.com. That's slantpod.com. And get 1,000 machines to help you grow your e-commerce store. All right, first piece of news is Campbell's 3D printing chicken. Okay, so this story has made the rounds on the internets this week because there was a recording that was leaked to a Michigan TV crew of a VP at Campbell's saying, hell no, I'm not going to ever eat Campbell's products because they're using bioengineered 3D printed chicken inside of the soup. I will have to, that is paraphrasing. Here is the direct quote. More specifically, Bally said, "Who buys our crap? I don't buy Campbell's products barely anymore. It's not healthy now that I know what the flip is in it. Bioengineered meat. I don't want to eat a piece of chicken that came from a 3D printer." This is the quote from the audio that came out, and I embellished because we don't have a bleeper, and it's too early in the podcast to curse accurately. Okay, so this is, it feels bad to be Campbell's because this is some upper level marketing who is a 1 hour profanity filled rant. Campbell's VP in the IT department, Martin Bally, said this. Okay, so let's start at the baseline. Does Campbell's use 3D printed chicken? The answer is no. The reason I can answer that without having to know anything more about the situation is because 3D printed meat can't make enough chicken to put in all the Campbell's soup cans. It's not 3D printed, it's not even made in a factory. 3D printed meat and mass-produced non-animal meat, so test tube meat, hasn't reached a stage yet where it can actually be mass-produced enough to fill all the Campbell soup cans with fake meat. The closest thing that they could get would maybe be tofu, and they can't do that because then it's not chicken. As far as the stuff being bioengineered, I don't know. Maybe they have some bioengineered chickens out there growing the meat, but no, probably not that. They're just typical chickens that all the rest of us eat. If you bought a chicken at Costco, you're eating one of the chickens that are used in Campbell's soup cans. Also, by the way, there's not that much chicken in one of those cans, so don't worry about it. That's the baseline truth here. There's no way Campbell's could physically use 3D printed chicken. Here's the other thing. Contextually, from kind of a business operations standpoint, the guy in the IT department has no clue what is in the cans. He runs the website and makes sure that all his systems are running. He doesn't know where the meat came from or anything else. So he has no credibility in this part of it. Sure, he's a VP of whatever in the IT department. Only a VP, doesn't say senior VP or anything else. So this is a dude who works at Campbell's and got recorded ranting about his job which shouldn't be taken as any point of fact at all. It's like having the marketing department tell you how a rocket works. No offense to the marketing department, but they don't know. They probably think milk comes from the grocery store. But I wanted to talk about this. I didn't want to put more fire on this because I was like, this is sad because it's just a tough situation for Campbell's. But like there's no physical way that 3D printed chicken could be used right now. And I thought I'd throw my hat in the ring as one of the 3D printing experts out there right now, just to say that no, Campbell's is not 3D printing meat because the technology is not available to do it. Maybe 5 or 10 years from now, there will be 3D printed chicken, but it's not today. So anyhow. All right, McNuggets are basically extruded chicken. That's effectively 3D printed chicken. That's fairly fair. But effectively is not the same thing as that. We're going to be precise about this. You could talk about mass-produced or like machine extruded meat all you want, but then you have to latch in hot dogs and everything else. Yes, it wasn't carved from a bison that somebody hunted down this afternoon. It is mass-produced food, just like chicken nuggets and that kind of thing. But that's not the same as 3D printed meat and doesn't have the same connotation of like test tube bioengineered meat. It's still a chicken. Still was a chicken. They just ran it through a blender. So still, it's important to have that discussion there. All right. But anyhow, poor Campbell's. Okay. Patents being stolen. I'm going to come back to that one. It is about the bed switching one. The first one I want to do, though, is the Nimble modular 3D printed prosthetic fin for runners. And what I want to do with this one is I actually want to show it off. Maybe show it off. Maybe, just maybe we'll get to show it off. It is, well, no, actually we won't do this one. I'm going to save that one for later. We have another one for an E3D nozzle that I'm going to show off. But there was a prosthetic fin that was designed for swimmers. It's a flexible, basically looks like a standard powder bed fusion sort of print that is used for amputees who want to swim. And it's a really nice prosthetic. Actually, let's go ahead and pull it up. 3D printed swim fin. This whole thing, this is one of the really great examples of design because you get to use the lattice shape to make an appendage that is potentially superior. You obviously don't have the muscles adding in extra strength with all of this, but it is a really cool item. And I want to give credit to really cool items because they're really cool, and you never get to see really cool items when you go through these things. Let's see here. I'm going to go ahead and we're going to go and look here at Nimble. So here we go. Let me make sure that reality is reality here real quick. And I want to make sure that you can all still spot me. But this is Nimble. And Nimble just looks really, really amazing because you can see right here that you have this core 3D printed spoke in the center of these main pieces. It's very modular. It's designed by an Italian company, so it has all the fashion that you would want. And this is a type of item that otherwise would never exist. But basically they're using a TPU printed part to store the energy as the person kicks in order to return it as they're kicking along. And right here you can see them right there with their wonderful little dolphin fin. But wanted to give a highlight to this particular item because it just looks really cool and it's really great to see really cool items like this. All right, next thing. We will go ahead and go, no, we won't go to the patent yet. We'll come back to that in just a moment. Before that, let's go ahead. We'll go ahead and share something else here real quick. Let me see. High flow nozzle, E3D. During Formnext. We are finally having some good content coming out of Formnext, which wasn't there a moment ago. And right here, you can see this little spinning doodad that was in the E3D booth at Formnext. This looks like just a cool print, just sort of a doodad sitting there. But what this is a Melt-Flow channel for a next generation nozzle coming from E3D. I love this so much, guys, because this is one of those beautiful pieces of engineering where you see it and it seems beautiful and simple, but the contours and the flow dynamics of this, I hope they put flow dynamics into that. It's looking simpler as I stare at it. I'm like, I don't know if they've actually put in the engineering to maintain laminar flow throughout that. It looks like they just compressed a thing and then figured out how to engineer it. But this way what they're doing is to have a high flow nozzle, you need to impart a lot of heat onto the material very quickly. In order to do that, you can break the material up and have multiple small channels. There is the Bondtech CHT nozzle, which they reference here, where it breaks, basically goes through a cheese grater, and that cheese grater is hot, so it can melt it faster. You're just getting more surface area. This is a way slicker way of getting more surface area, and also doesn't create the weirdness and flow dynamics that would, cause jamming or incomplete melt. This is a really, really good way to make sure that the entire thing is perfectly melted just right and then recombined into the nozzle as it's coming out. This is so nifty. Check it out. It is such a cool design in general, and I really appreciate this type of engineering because it's such a clever design, and it's going to be very manufacturable too, because this can be made in 2 halves. You can probably machine it too. I like all the ways of putting this together work really well. So it's just exciting to see. Okay, now let's move on to a small patent dispute. Small patent dispute. This came up. I really have to thank Carrie over at Fabaloo for this article because it is so well kind of researched, and I will give the highlights. Go to Fabaloo, read the full article because it's very good. Okay, I want to right here. Okay, sure. This thing. This is the swap mod system for an A1 machine. And what it is a bed, what Carrie's calling a bed cycler system. So print finishes, it then runs a little bit of G-code that pushes that bed off, and then it goes and grabs another print bed. This has been around for a while. From like a business product standpoint, if I was doing it, I have very little interest in these type of products because they're still really limited and not very good for production. They're good for small scale garage production and can be nifty for certain machines and like prototyping and that kind of thing. But they're not very reliable, and they have a number of different issues with them. You also have Yan Yan at Print Farmers made a version of this kind of thing too. And we're going to find out that there's several more versions of this along the way. I'm going to leave that up for just a moment, and then I'm going to read the article over here so I can run through it all. This item is being made by Chidu Box. I've always said Chidu Box. Is that how we say it around here? But they have made a version of this. Chidu Systems Plate Cycler. This is being made by Chidu Systems. They're selling it. However, the swap mod kit is made by a gentleman in Germany who raised $80,000 on Kickstarter for the files designed with this. And the Chidu Box system is one that can be added on externally. However, there is a patent held in the United States by a company called R3, which doesn't really make an FDM machine, but also doesn't really engage with this patent at all. So, Chidu Box didn't really, doesn't sell this in the United States. Here's the thing. This is kind of 3D printer industry insidery gossip, but there's a whole like, ooh, this is gonna be a war coming. Let's grab popcorn. This isn't gonna be a big deal. Here's the thing. Let me put like proportion of industry in context. So the swap mod machine raised $77,000 from 1,000 backers. For comparison, I think the Fiber Seeker just raised 10 or 20 million in pre-orders on Kickstarter for a 3D printer that is a professional-ish 3D printer. Fiber Seeker, let's see here. Yeah, here we go. They have raised, as of this recording, FiberSeek has raised $3 million, also from 1,000 backers. Dang it, my point is gone. They've raised way more money. My point, I'm still going to go with this point, but the point was that the number of people who are interested in kind of increased volume production from their machine is a very small market. to where basically no one cares about it. And if Cheetahbox released their thing, if they make $100,000 or $250,000 off of it, it's probably worth it to them to have it around and just have it stored. But the problem with this is that the system, the accessory, is going to be obsolete with the next machine release. So you have to continue building this plate cycler accessory forever. It doesn't take much to get around the patent, and enforcing the patent isn't really worth the damages that you get from it because it's not taking any sales away. The open source one exists, which would also technically be infringing on the patent, even though they're in Germany where the patent isn't in effect. So this is all drama of a small industry because there's 3 similar ideas out there. One of them has a patent, another one is open source, and the other one is actually in market. And it's just kind of hilarious to see because, not to be a jerk, but we could design this, I could get this knocked out in a weekend. It's not that difficult to make this type of a system. It's really useful and nobody else needs to spend their weekend doing it, but like the value of it is not very great because there are not very many people interested in it or who need it or have the problem to where there needs to be a fight over it. If R3 wanted to enforce their patent, if Cheetahbox went and sold it in the US, that wouldn't matter. It wouldn't pay for the lawyers to get whatever damages you would get from them. So this is kind of a nothing burger thing, but it is a really interesting piece of history because there's all these ideas floating around. And I kind of wanted to highlight this one because it's a cool idea that's floating around. For me as an engineer, it's a nifty system because it's very simple and very slick. And a lot of people have built robot arms and that kind of thing for switching plates. But these systems are a really good way of switching plates. They're just way more reliable. So anyhow, I had a lot of fun looking at this, and it's just something that I wanted to kind of bring up, and it's good news. It's really good news. Carrie did really good reporting on this, pulling up the different sources, researching R3. R3 has a machine. Oh, it is an FDM machine. They made the R3 machine so won't get burned, cut, or scraped. Operators won't get burned, cut, or scraped. I think they made a 3D printer in a box. Sorry to R3. Automation eliminates the need for operators to engage with the printer without the need for hands-on administration. There's less risk of injury. Guys, printers, that's a tough sell. Printers are pretty good at not hurting people. Okay, stop that right there. Going back to regular layout here for everybody else. Let's see what folks have to say in the chat here about this. What are the claims? Just swapping? Yeah, it's just swapping. It would almost be a patent troll case, but it's not even that because the troll wouldn't do it because it's not even worth their time. Well, the troll, for those who aren't familiar with patent trolls, they're folks who will buy a patent and then sue whoever might kind of be infringing on it and get paid like 10 grand just to make the lawsuit go away because the other party doesn't want to pay 20 grand for lawyers to end up with nothing. Okay, alrighty. Let's see here. Moving on to the next piece of news. Oh boy, that's all the stuff, guys. Oh no, Walmart 3D printed stuff. Hold on a second. Gotta show you all this because this is fun. All right, going back to this. Hold on a second. I gotta share this. Gotta share this. Right here. Share. And we will get rid of the stupid ads. My goodness. This is a 3D printed Walmart wall. Isn't this cool? Hold on a second. I want to see where I am. Right here, I'm pointing like this. This, right here is a 3D printed Walmart wall. This is, we reported about this a few months ago that Walmart was starting to do this, but they're doing additions onto main supercenters that are 3D printed like this because they're just making a warehouse. They just need concrete walls put up. I don't know why they're not using concrete tilt-up buildings. I'm gonna guess Walmart's just kind of doing the experiment. Because it's a cool experiment. But this is just a really great example of a real company using 3D printed buildings live out there being active. And this is kind of a side storage spot. So there's not like customers inside of it because Walmart's doing a test of it all. Also, Allquist 3D, they have their just released a new 3D printer, which is their thing. But I wanted to show you guys that because that's a 3D printed building. And you wouldn't be able to tell that's a 3D printed building. I mean, you can if you're close at it, but from a distance and you squint, looks like a Walmart. So that's great because that's just really indicative of how much everything is going to kind of normalize, because we're going to start seeing this stuff all over the place and it's not going to be interesting. We're just like, whatever, they 3D printed this Walmart, moving on with life, which is how it should be. The process shouldn't be interesting, but the result should be interesting and useful. And a 3D printed building is interesting and useful. Okay, alrighty then. All right, chat, get questions down there. We're going to circle back around to you guys in just a moment. Okay. All right. Updates, company updates coming here. Teleport and Tangled. We are at 27. All right, Teleport. Big release on Teleport this week. Looks kind of subtle, but it's a big release. Teleport and Portals both had a feature released called Catalog. Catalog, at this moment, is 5 to 10 free 3D models that you can start selling through Teleport and Portals. When you're in Portals and you're adding in files or whatever else it was, there is the option for search, find, upload files, or Catalog. You tap on Catalog, that list of files shows up with previews of each one of them, and you can start selling them. Right now we have a set of cookie cutters, we have some wheels, brackets, gears, some of our phone chargers, that kind of stuff are in there. It's a really good way to get started because there's some really great models that have been designed by us and are very good. Well, what this means, though, what we're going to do with Catalog, and I'm willing to reveal this because Catalog is out there now. Catalog allows designers to license their models in a way that was never possible before. Because before, designers would have to share their files with people, and then once they're shared, they're gone. If the person can pay for the commercial license, download your files, and then continue using it, and you really can't stop them using it. But now, the designer can. Designers will be able to upload files to Catalog, and for each sale of a print of that file, they will get a royalty. And the sellers will be able to get access to files that they otherwise wouldn't be able to get access for. And if the designer ever wants to stop sharing that file, that designer can remove the file and all the listings selling it will disappear, protecting their intellectual property forever. So they can rotate through dragons, they can do whatever they want, they can create new inventions and then pull them back or just have their store, whatever it was. This is really great because designers are now uber protected and sellers have way more items that are available to sell integrated right into Teleport and Portals. So this is super exciting for us. This is the first little phase. You will see more of it roll out here over the next few weeks or so. So this is, super excited about this. More broadly, with Teleport and Portals and that kind of stuff, orders are going out. And Black Friday, we had prepped for it, we had trained, we had struggled, we had been ready. And when Black Friday came, by golly, I think we have the fastest shipping times we've ever had because we've got it all ramped up. Most orders are going out in under 2 days. Right now we're sitting at about 82% of orders are going out in under 2 days. A few go up to like the full 5 day, but they have like 5 or 10 parts inside of them or something and something weird going on. The vast majority of orders going out next day on almost everything. So we're super fast on that right now. So sellers are able to get their parts out and people are able to get help with their backlog. Okay, let's see here. Teleport is there, operational, taking care of everybody. Portals there, operational, taking care of everybody. It's looking very good. Alrighty then. Hold on, I'm checking stream just to make sure reality's reality. Ooh, that's got a lag on it over there. But that's okay. Here we go, moving on with life. All right, so Teleport is good. Update on Tangled. Tangled, we have just released gray filament on 3 kg spools. Tangled has forever been black PLA and will continue to have black PLA that costs $10 per kilogram. And we have just introduced gray, which costs $10 per kilogram. The reason we don't do more colors and the reason it took so long to get to gray is because there's so much optimization in the process to where if you're changing colors and focusing on the changeover, the rest of the process doesn't get optimized. Right now, Tangled is running very efficiently, and we finally got it into like profitability at the $10 per spool, and we're working to extend that even more. In the new year, we'll have more announcements here. I think we have roadmap on that. We'll release the next version of the master plan to, maybe it's possible to get to $5 a spool. I don't know. It might be doable. We'll see here. But anyhow, that is now happening. We have gray, which is really useful because a lot of people use Tangled for like prototyping and for large format stuff. And so they're going to paint it. And painting black can be a little bit rough. So we now have gray, so people have a light tone color. The reason you do gray rather than doing like a white is because if there's any problem, if there's any discoloration or anything else, or stain or speck or non-trivial fingerprint on it, white looks gross. Plus, if you're transitioning from black to a color and then back to black, you want that transition to be clear. And white can't do that. In order to go from white to black, you basically have to fully purge the machine, remove the screw, scrape out all the black, and then move on with life. Gray is more forgiving because gray can absorb a little bit of the black if there's residual in there from the previous batch. So it's just a much more efficient run while still giving you light colors. There'll be waste transition filaments starting to come now that we have to move between colors. But there is gray available over there at tangledfilament.com. And it's available for members and non-members, and it is $10 per spool, just as before, or $10 per kg. The main spool is a 3 kg spool right now. We have a new 1 kg spool coming out. This new 1 kg spool is giving us trouble because it's not staying in the same dimension, but it should help everybody with bamboo compatibility. So we should have that finally released for people. So the number one printer brand in the world right now will be able to use Tangled Filament in the AMS, which has been a thing that's been slowing us down a bit. You can use Tangled on a regular bamboo machine if you're just using a single spool, but if you're using the AMS, the large heavy-duty spools that we use don't fit inside the AMS. They're about 3 millimeters too wide because bamboo did that on purpose to jack with everybody. Okay. But that is that. All right, let's go ahead and run through questions here real quick. Yeah, there's no pet G on Tangled. There won't be pet G on Tangled for a bit. Okay. Michael Peterson, it says beta test in front of it. I don't know what you're talking about, man. Hang on, we'll get back to you here in just a moment. We'll finish up the rest of the chat. People are talking about stuff that we need to talk about live. That's fine. We'll get to that. All right. So, the interview for this week. As you know, for the last few weeks, we've been doing interviews with industry professionals from around. We've talked to Shop Nation. We've talked to Gyroline, which have been making high-precision auto tools. See that last week. We are going to go ahead and this week welcome Pawel Slusarczyk, who was historically a reporter, but he currently works with Bamboo Bamboo directly. We had this conversation a few weeks ago, might even be a couple months ago or something. It was right the day we talked to each other. We did this interview the morning of the H2D release, and he couldn't talk about it because it hadn't officially been released yet. But it was fun because I got to talk to him in the context of like where the industry was going. And while there were restrictions on it because he wasn't like a freelance reporter anymore, it was still a really fun conversation about the industry. So I recommend enjoying it, and I'll see you all next week. Have a great week, everybody.
So Pawel, here over the last few months and years or so, you've been doing a lot of writing, and one of the things that you've brought up are the 3 laws of the additive manufacturing market. So I'd like to start there if you'd love to give everybody an explanation of what they are, and then we can go from there.
Sure thing. First of all, I will say that it were created over a year before I presented them to the public, and honestly I was a little not sure how they will be and what the reaction will be. Fortunately, I was able to publish them on the 3dprint.com one of the most renowned media outlets about additive manufacturing, mostly because of my long-time friendship with Michael Multiho, who was at that time chief editor at 3dprint.com. Anyway, maybe I will tell simply what the three laws are and then dig more into it. So first I will just present them, then I will explain a little bit what is behind of it. So the first law basically says that a company that is viewing itself as a 3D printing company won't achieve any success aside of 3D printing market. So if someone is setting up a company and this company is perceived or identifies themselves as a additive manufacturing company, there is not much really room for any pivot in any reasonable future. That's one thing. Another thing is the second market law says that a successful 3D printing company will be always smaller and less profitable than any other successful manufacturing company working in any other sphere of industrial manufacturing. In other words, the biggest 3D printing company in the world will be always smaller, less profitable than the biggest CNC milling manufacturer in the world, or the injection molding manufacturer in the world. This obviously needs some further explanation later because it's kind of tricky, but if you understand why, where did I come from with this idea, then you agree that it's true. And the third market law says that the growth of the additive manufacturing market is not connected to the growth of companies that are creating, are part of AM market. In other words, the market may be growing, but the value of companies creating this market may be diminishing. Or in other words, there is also a similar saying I created that the 3D printing market is growing and it will continue to grow, while the companies may collapse and will continue to collapsing. So this is basically what I came up in 2023 and published it in August 2024. Probably we have like today full year anniversary of publication. I just realized that it could be the same date. Yeah,
it might be. That's perfect then. Well, yeah, break those out a little bit. Like the idea that I fully agree that like a 3D printing company that parlays itself as a 3D company is really, really limiting itself. But at the same time, lots of companies have pivoted from things before. So what is the reason for the first law?
Okay, so in 2023, I was very disappointed with 3D printing industry. I wasn't disappointed with technology. Technology I always liked and still like. But the industry got me really, really frustrated, depressed. Maybe later on I will talk about it more, but nevertheless, I wanted to go out. So I was looking for opportunities to do something else in my life. The idea I had wasn't smart, but it was the best idea we had at the time. So we moved from 3D printing industry to interior finishing industry. I had a colleague that was working in this area, and he convinced me and my wife to, make a pivot. So obviously we started doing some things concerning interior designing, but we still wanted to find come up with some applications that you could make on a 3D printer and will be suitable to this new industry. So the first product we developed were very simple covers for light switches or electric sockets. So the thing you put on the wall and then you put electric switch or electric socket. We also had technology of UV printing, so we could do whatever design we can, and it looked really, really awesome. Also, we went to this eco kind of direction, so we used very specific materials, not PLA, which is not
Sure. Yeah, you can't use that in UL
eco,
standard. Yeah.
but there are several other materials on the market that are truly biodegradable or compostable if you put it to the ground or soil, whatever. Anyway, so we started doing this. We put some press releases, which were very well received, and it got some traction in media, but basically no one were ordering this. There was an e-store set up. The designs were wonderful. We were presenting those products on the conferences, fairs. Everyone loved it. No one was buying this. A couple of months later, I came with another idea with lampshades. So I went even further again with ecological material that after like 2 or 3 years, you can take the lampshade, put it into ground, and then it will disappear in a couple of months, maybe years, but it will disappear. Different materials. Again, a lot of traction, a lot of media coverage, basically none to nothing sales. So I started to think about it, analyzing this. I mean, why? Why companies are keep going to us, asking for a 3D printer, filament for a 3D printer, or they want to order us to make a 3D printing product, but they don't want to buy our products. So maybe because we are 3D printer company.
What was
Maybe
the name of
we
the company
still
at the time?
Greenfield 3D. Greenfield.
Okay.
Greenfield.
Okay.
So it had 3D in the name.
Yeah.
And before that, obviously, the company, but it was a startup, what was my second company. It got recognizable because of the very interesting project we did 21, 22, which was we created our own filament based on raw wheat bran.
Oh, wow.
Filament was fully biodegradable and it looked like wood. So for example, wooden filament, if you print something out of it, it looks like cardboard.
Yeah.
But with this filament, it really looked like wood and it really started to biodegradable after several months, depending on the conditions you were holding it. Anyway, so that was my idea, that it's very hard, almost impossible for a company that is seen, is perceived as a 3D printing company to pivot to completely different market. And then I realized that it's not like we are not the only one. So obviously you and everyone else listening to this podcast probably heard about a company called Materialize. Yeah, so Materialize is like the legacy company that created 3D printing market in early 90s, that was the very first software AM company, one of the biggest AM service provider in the world. But I don't know how many people is aware that since mid 2000s, Materialize put enormous effort to enter the fashion market. They did a lot of
a lot
really
of demos.
interesting applications.
Yes.
And nothing. I literally took part in one of the fashion presentation where models were presenting their dresses, skirts, whatever,
accessories, all the things.
Accessories on a fashion show in Poland, and no one cared. I mean, it was something you could never make in any other form. There was something that you couldn't replicate, and you probably see it for the first and very last time in your life. And there was complete indifference.
But isn't that also kind of just the education gap? Because a bunch of fashion designers will see this 3D printed item, and because it's branded 3D printing, it also is perceived as complex and difficult, especially at that time. Wouldn't that
Yeah, but,
also
well,
be kind of a component to it, as opposed to just being 3D printed?
I don't think, because Materialize tried to do this for at least 15 years.
Okay, that's
I
fair.
mean, come on.
Yeah, 15 years is a decent amount of time.
Yes. And again, in late second part of 2010s, they introduced the 3D printed glasses. Okay, so that the use of SLS technology and all the new finishing techniques that they were applying, coloring, smoothing, and so on. So they also started to presenting it on a very large scale. They also developed a system where a person could measure face or
Sure.
how the eyes are located, and then easily design its own glasses. And it also didn't work. However, Materialize is the biggest manufacturer of 3D printed glasses in the world. They just do it for another brands. They couldn't do it on their own Materialize brand, but they did that. They're doing this on a large scale for anyone else. So if someone decides to start a glasses company and they want to make it using 3D printing technology, instead of buying own 3D printer, they go to Materialize. And Materialize will do it with great expertise and for probably very good price. But if you are a glasses company, optics company, you are not 3D printing company, and the opposite.
This
Again,
is fair.
another example, Stratasys, who was also trying for a couple of years to enter fashion market with 3D
Right.
fashion technology. Also, complete. I mean, those applications are interesting, to say at
Right.
least. They are interesting. Some are really awesome, but the complete indifference of the fashion and other designing markets is depressing. So no one cares.
This is
because
true.
Stratasys is industrial company.
Yes. That's the thing. Like, it's not necessarily the fact that they were 3D printing, it's the fact that they're so removed from the actual industry that they're trying to enter. And 3D printing also just has kind of the shiny object problem of, oh, we can make anything. What is one of the industries that we should go make stuff for? And they pick that, but they don't really commit to it because they still have production partners who are currently making parts, so they can't focus on the glasses in the way that a glasses company does. It's so easy for a 3D printing company to become unfocused that all of the side quests are effectively side quests to where they dip their toes in, and 15 years is a pretty good commitment, so I'll give them that. But at the same time, 15 years when it's a side project is less of a commitment than saying we're making glasses now and that's going to replace our entire rest of the rest of our business. So there's sort of a commitment limitation on there, but it's absolutely true that, like, if you're creating a 3D printed product and you say this is 3D printed or that we're a 3D printing company making this product, that does hurt your branding because people think, oh, 3D printing as a service rather than an injection. Nobody touts the injection molding of a product, but 3D printing really thinks that the process is part of the brand very often, and that's kind of burnout.
Fortunately, I hope we are behind those times when companies were buying 3D printer and were expecting the business to organically grow because they have 3D printer. Like, hello world, we are a 3D printing company. So
yes, exactly. Yeah, exactly.
Yeah. Okay.
Go ahead.
The second law, or you want to add something? Okay.
No, let's go ahead. Second law.
This is kind of tricky because first of all, you have to understand what 3D printing is really about, and if you realize it, then you will, it has to be smaller, it has to be more limited. So historically speaking, 3D printing technology, additive manufacturing technology, was created by very small number of people, engineers that were trying to create the best possible technology for making prototypes.
Correct.
So they were targeting also very limited target of people. So R&D teams at manufacturing companies or scientists, laboratories, and so on. So 3D printing technology basically was created to make unique objects that were supposed to be some sort of tryouts, not for final use. So there are 3 advantages and 3 disadvantages where 3D printing is better and worse towards any other manufacturing technology. The advantages, as a rule, because there are some exceptions obviously, but as a rule, the advantages are this is the cheapest, fastest technology, and it also provides the most complex geometries that are possible in 3-dimensional world. But the limitations are the quality of surface or dimensional quality, the size limitation, meaning the more bigger the printed part is, the more problematic in manufacturing it becomes.
Correct.
And the third is it is not suitable for mass manufacturing because it's how it's by applying layer by layer of material is great for 1, 2, 3, several pieces of parts, but when we take this process, when we try to scale it into like hundreds of thousands or million of parts, and the size is significant, meaning it's bigger than 10 centimeters, then it starts to become really, really problematic. So the question is, obviously, during the next years, the technology improved a lot, so printers started to be used for making end parts. The more reliable the printers become and more certified the processes started to be, they also started to be using for small batches of products, end products. But at the end of the day, everyone were using them to make cheaper parts as fast as possible, where quality doesn't matter or is secondary.
Sure.
And the size is obviously limited. So you cannot use this technology for making 2-meter long parts.
Sure.
Yes, you can on a certain machines, but as a rule, you don't. It's very, very difficult. So you always buy this machine when you want to save money. If you want to save money, you never pay the most money for it. So even if you buy a metal 3D printer that costs, I don't know, like $1 million, you buy it only because all the possible alternatives to making a part is more expensive. So you cannot expect from an industry that specializes in creating the cheapest possible products with the lowest acceptable quality to be the most expensive or profitable business in the world of manufacturing. Simple as that.
But what aerospace inverts all of those rules, because yes, while it is lower quality than like a cast part, all of the other advantages of it create a higher quality result to where companies should be able to charge reasonable margins for the $1 million metal machine over there because the advantages of the engineering come through. Isn't that fair to presume on some of those?
Yes, but yeah, of course, you're right. But aerospace industry is small. It's tiny. Compare it to, I don't know, the big industry.
Like going towards like full worldwide or something like that.
Yes.
Okay.
So yeah, I mean, 3D printing technology is perfect for very small niche applications like energy, like atomic energy. How many atomic plants are made every year in the world?
Sure. Okay,
How
that's
many maritime? For building some specialized parts for ships. How many ships are being made on a daily basis? Now, when you compare it to the automotive industry, where 3D printing is also very beneficiary, no one is using 3D printing to create end parts for normal cars.
That's fair.
that are used for sports car,
Yep.
that are used for special purposes cars. So everywhere when you need something very special, very unique, and this is where 3D printing suits best. So you won't use. Okay, this is not a maybe good example, but it started to happen in China. You won't use a 3D printer to build a phone case. You will always mill it. However, yes, there are few brands, Chinese brands, that started using metal 3D printing to create some parts of phones. Even Apple, also, as we know, started to using titanium to make some parts to the Apple watches. But those are only selected parts where, as I said, this is the cheapest possible alternative to all the other techniques. So this is why it was chosen. So it's always the cheapest possible solution that we choose in terms of 3D printing.
What do you think would need to be created in order to allow it to have value capture in the market to where it's actually, increasingly profitable and running away with it, but also maintaining the scale to where it has the broad reach?
So first of all, and I will also expand later, do what Bamboo Lab did. Step away from 3D printing industry. Bamboo Lab is no longer 3D printing company, in my opinion. Bamboo Lab is consumer electronics company that makes 3D printers. Okay, so this, what I'm saying is like semantics. You can name it things, whatever you can. But if you start digging into what I said, understanding the logic, you will find that if you do certain things like Bamboo Lab and probably Creality, which is also another company, you can classify as consumer electronics company, not 3D printing company.
Sure.
Then all those laws we are discussing are not applying anymore. But there are different things that you have to take for consideration. We can go back to it later. Yes, if you are in 3D printing sphere, 3D printing market, 3D printing bubble,
yes,
you are surrounded by those laws.
Yes.
So obviously,
that's fair.
The third law is also very straightforward. I don't think that there needs to be much of explanation. So the market is growing. So whatever market report you will take, it will always show the 3D printing market is growing. It is growing because it's still very small.
Yes.
And there is a lot of place for improvement and a lot of space for adoption. So it will grow. However, the number of companies creating this market is still way too high.
Yes.
So simply, it's too many companies on still too small market. And this is why companies are struggling to be profitable, because fighting competition, they are lowering their margins. Still, they have to expand drastically in terms of R&D. So this is basically the reason most companies, most startups either went bankrupt or are struggling to be alive still. And all the companies that survived this recent slaughter is Carbon, which in 2015 presented revolutionary technology, and the expectations for this company were like huge. It is like one of the game changers. So
it was the first unicorn.
Desktop Metal was fake from the day one, but Carbon was and is real. Their technology is real. However, again, when you take the 3D printing hype and you looked on them, just like what they do, they are just a company that makes 3D printers making parts from resins, very fast 3D printers, but very fast compared to other 3D printing technologies, not very fast as a process.
Yes.
So unfortunately, you still can say that they kind of disappointing right now because they are not as huge as the world expected them to be 10 years ago. They're just,
They're there. They're still operating. And they're in an interesting sort of a basis because I always use kind of carbon as like the example of like the technological improvement is great, but it's like saying, oh, you have a faster chip. It's like, great, but what does that allow me to do? Again, it comes back to the applications. And carbon has always been, I always use them as the example of like speed isn't really the main variable holding back 3D printing because they've had speed for forever and they could have had scale for forever. But the big vicious circle of all of these things is that as a company gets larger and makes larger and larger volumes of parts, again, the margins start to hurt. Because like in the production business, it's great when you get the first client and you make 1,000 or 10,000 parts for them, and then they come back for 100,000 and they're like, great, since we're buying so many parts from you, we're going to pay you less per part, which is the traditional deal of production manufacturing. So companies get into this death spiral to where they have less and less return for more and more work. And that's always kind of the very few people have cracked how 3D printing scales into that, because it has effectively flat inputs the entire time while increasing the amount of output, as opposed to like a mold and that kind of stuff that amortizes over time. But
exactly.
Yeah. But yeah, the challenge is, you're right about all of these laws really applying to within the 3D printing space. Because there are examples of lots of companies that have broken out of their industries before and done this kind of stuff. And like you made the point of like consumer electronics. But the 3D printing industry largely just needs to get out of its own way on a lot of this stuff and just run. A Bamboo Lab is a great example because, like you said, they're a consumer electronics company. The example I always use is that they're the only one that has their logo in view of the time-lapse camera on their machines. And that's basic consumer product marketing and that kind of stuff. But no, none of the other machines actually do that. And it's a simple move, but it's not one the 3D printing will make.
Because this is like a completely different approach.
Yeah.
If you say we are 3D printing company, you limit yourself to all possible factors. I'm not referring right now to Bamboo Lab or any other company, but obviously, this is like the heritage 3D printing has, desktop 3D printing. What will community say?
Yes.
Like how they will react. So the community is like a very tiny group of people that have some rules and some code that was created in 2000, in second part of 2000s. Early 2010s. They don't really apply anymore what is happening on the market, but still they are very important voice.
Yes.
What I'm saying is, I'm not saying that they are wrong, they should stay silent or whatever. No, it's like if you are a 3D printing company, you have to take this for consideration. So, for example, I suppose a lot of stuff that the Czech company Prusa Research cannot do is because of their legacy of open hardware icons.
Yep. Their entire brand and culture is that direction.
Yes. So they keep limiting themselves because of that, because they cannot make any other significant step forward. Because the community will turn. If the community will turn out from them, then the company is finished. This is when you start making your business as a consumer electronics business, and you choose 3D printers as your core product, you apply to completely different rules. So first of all, in consumer electronics, this is economy of scale. Okay, margins are important, but I will give you an example. Filament. manufacturing. So the prices of filament went down a lot, and I still remember your controversial at the time video when you started asking why filament is so expensive, right? Like 2 or 3 years ago, I don't remember exactly, but you did that material. So anyway, the truth is the cost of material was, let's say, $10 per spool, and you were buying it for 23, and everything else was margin. And this margin was needed for a company to survive. First of all, the company that was manufacturing this filament had to survive, so the margin had to be big enough, but also all the distribution also had to have something out of it. So if you are selling like 500 spools and your profit is $5 on a spool, it's still tiny business. It's not something you can make a career out of.
Totally.
So this is where we started in 2010s, obviously.
Yes.
But the more you are starting to make filament, the margin can be lower and lower and lower. So imagine this, your absolute net profit after all the cost is just $1 per spool. So it's very tiny.
Yeah.
Unless you're making 5 million spools per year. And then this profit is starting to be reasonable. It's $5 million you have in your pocket each year. So you have to achieve 5 million spools per year number. And obviously there are Chinese companies that does it, that make such numbers, which are still impossible to achieve by European or American companies. But this is a completely different approach. So if you ask
it's an end goal
5 years ago or 7 years ago someone, what about $1 profit from a spool? No one would take it seriously, because the actual money you will get from the whole business was like, so I will have like $100 per month. So this is the very first difference, the economy of scale.
The size of the goal that you're operating in, of like, we're going to start small and we're going to grow up from there, as opposed to, no, we're just going to start big and then kind of figure it out backwards from there, so that you just have the math working for you right off the start, but then you also have just this huge competitive advantage. And you're right. Most independent filament manufacturers don't really do that very well.
Listen, in terms of bamboo, we are talking about startup, which is a startup. It's still a very young company. The company was created 5 years ago, but it started being operational 3 years ago.
Right.
And but people that created Bamboo Lab were pretty experienced people.
Oh yes.
From DJI, engineers, but also with the knowledge how consumer electronics company should be operated. So when you look at the printer, so again, back in the day, every printer that was presented to the market was different than the previous model. And from a manufacturing point of view, it's crazy, because you have to, for each generation of machines, you have to build
a whole new line.
Yes, everything. Then if you expire previous model, you still have to keep it up for spare parts to be fair to the customers. So when you are like an engineer or a new technology geek freak, you don't think about these things, such things. You are not aware of it. So the success of companies like Royalties, Bamboo Lab, also Lego, Anycubic, is basically, those are people that are rooted heavily in manufacturing. They started making 3D printers because of several reasons. Each company, group of founders had their own reason why 3D printers, but the common thing is where to get parts, the best possible parts for the best possible price, where to manufacture it, how to make logistics. So for example, if you talk about, again, back to filaments, if you talk to the biggest filaments manufacturer in China, you talk about containers.
Yep.
Not pallets.
Oh, no.
No, containers.
No.
How
Yes.
many containers do you want to order?
Yep. Exactly.
So-
There's no way to make it work otherwise.
Yeah.
No, yes, the scale. This is the scale that is necessary for 3D printing is so unapproachable for so many people, because the scale everybody interacts with is the one machine and maybe 20 on a wall or something like that. So the conception of, yes, a pallet load of 3D printed parts or a pallet load of filament is just so large compared to what everybody interacts with, that all of those past interactions inform how one of those would-be entrepreneurs build in. So like if there's a kid watching this or something like this, you shouldn't interact with 3D printing solely if you're starting up the company. You need to go see the world a little bit to realize what big can be. And that gives you such a different context of it all. I don't want to bash on Prusa or anyone else compared to Bamboo, but I think Prusa, again, like the heritage that they had was coming up from the closet and Joe building out more and more and more stuff and growing organically kind of with the community, as opposed to starting with, we need to make 1 million 3D printers in 2 years, which was effectively what Bamboo started with, of like, we got to go from nothing to 1 million machines just like that, because that's how you make a business that's successful in all of this stuff and actually can scale and grow and then own the market. And they did that, and now they own the market, starting with a core innovation that's the main idea, and then launch that completely and commit to it fully, to where you either wildly succeed or wildly fail, because many people stay in like the safe zone of like, we should just kind of iteratively grow, and that is the safe zone, but it also lets everybody else rush past you if they're willing to take the higher risk. And Bamboo took a gigantic risk in the way and scale of which they executed, but they're also just so good at execution.
Yeah. Well, this is another thing I realized. Execution is very good word. The other word, very important to understand, not only Bamboo but Chinese companies, is focus.
Yes.
So they are focused on the job. So
Yes.
I spent 2 weeks in the office. Apart from stereotypes, it's not like a place where people work for 17 hours per day and are exhausted. No, it's like normal job, office job, right? But they are focused.
Yes.
So for example, we, the Europeans, we want to talk about spread ideas, brainstorming and so on. In terms of Chinese engineers, managers, it's better to come with solution. So this or this.
Yeah.
Okay. We think it's better this. Do you have anything opposite or not? Brainstorming is European thing, maybe American as well. I don't know Americans as much as Europe. I know Europeans. So yeah, we just love to discuss and we are very creative. Okay. But when it's coming to sheer execution of the idea, I believe Chinese are perfect in that regard, and we can work as hard, but we are not focused. It's like this cultural difference between us. So
the
I would argue that
movement.
we are much more creative. But they are much better in in making the idea or a creation
turning
into
the crank.
Physical form. Yes,
turning the crank. They're fantastically good at that, because yes, once there's kind of a beat and a direction, just moving in that direction, the Chinese are so much better than most of the other cultures at. A lot of people attribute it to like the number of hours, but like number of hours only gets you so far. You have to be efficient in those hours, and again, like you say, the focused, so that you actually get done what needs to be done in a reasonable amount of time.
No one really spend much time on secondary topics.
Yes.
It's not like there is no fun in the office or they don't drink coffee. There is a lunch break. Everyone goes to eat something outside the company. They come back, return to work, still chat a little bit, then just focus on the work.
Yes.
Those are very small details. I cannot really describe it, explain it, but if you felt it, experienced it the way I did, so it's just different. And this is like the key answer why they are successful, why the other nations, other areas of the world are not.
I'm gonna use work-life balance, but that's not what it is. Like it's work-life separation, because many people, especially in the Western countries, believe that like work-life balance, your job should be part of your life, and it works together, and they're cohesive, and all the rest of this kind of stuff, and they don't interfere, and your job is family, and all these kind of things. Where it's like the Chinese still maintain the sacredness of work, of like you're there to work. There's a very specific job that we're doing, and we're going to get it done. And then you can go home and live your life, but your life isn't necessarily coming into work because we're working right now. It goes back to focus, work-life focus. Do the thing that you're here to do while you're here doing it, and other stuff isn't what we come in here. But no, it is fascinating. It's cool that you got to go over there, because yes, the culture types are so different. And many people misunderstand it too, because everybody has kind of a China 15 years ago perception of China, as opposed to China today. And China today is just a very well organized and well laid out execution machine.
Exactly.
Yeah.
So yes, there are obviously some things that are not so good in China.
Absolutely.
We won't deny it, but
Absolutely.
It's not like the best possible place to live. It is. There are places where they are really, really great, but there are places which are not.
Absolutely.
China is by area one of the greatest countries in the world.
Yep.
So obviously it cannot be equal on every square kilometer or square mile, but
not at all.
Again, when we talk manufacturing, when we talk deep tech, probably software already as well, the commitment and focus are the key factors. Long hours, it depends. There are a lot of places in Europe where long hours are still like a common thing when you work for 12, 14 hours per day.
Mm-hmm.
No one calls it slave labor. It's just,
It's part of the gig of starting a startup. You have to, otherwise you don't survive. I'd like to shift gears just a little bit. You went on a LinkedIn history spree for a while, writing a bunch of really, really great articles about the history of the AM market and that kind of stuff. Why LinkedIn, and how did that go, and how did that whole part of your life go on? You're still doing it, but like, how'd that get started? Where'd that come from?
Okay, so as I mentioned, there was in 2023 and first part of 2024, I was so disgusted with additive manufacturing industry, both in my native Poland as well as worldwide, that I just wanted to get out. Unfortunately, the more I'm like condemned to 3D printing. I tried like 2 or 3 times during all those years. It's my 13th year in the industry already, and 2 or 3 times I tried to step away from it, try to find something else. Not really 3D printing, and every time I failed. So the last attempt, this interior finishing business, it was completely brutal collapse. So in mid 2024, I can say that we went bankrupt. I mean, we didn't went bankrupt in like formal way, but it just we came to the point where we cannot finance it anymore. We have to step up. So we lay off all the employees. We closed our office, which was almost 250 square meters. So it wasn't that small.
Yeah.
And we just fire sale all the furniture, equipment, whatever, come back home. Okay. Yep. So what we are going to do right now, obviously we won't be running 3D printing service bureau anymore. We don't want to make any new products. We invented enough. So me and my wife decided to go back to editorial. I mean, first it was me. She joined like 2-3 months later. So anyway, I started doing the very same thing I started doing 13 years ago. So 13 years ago, I created the 3D printing center in Polish, Centrum Druku 3D, which is still the biggest website about 3D printing in Poland. And I was running it for 11 years. I sold it in 2023. 23, formally 24, but nevertheless. Yeah. So I decided I will come back to writing, for starters, to reinvent myself. But I didn't really wanted to write news stories from the 3D printing industry again, like I did for past 10 years. This was the first reason I quit it. So I was thinking about what can I write on a daily basis that will be interesting enough for people to read, and it will be something unique, extra. So I don't know, out of nowhere just came out, what about what happened in 3D printing on a given day? So it was, I suppose it was 12th of May 24. So I opened computer, it was Sunday, opened computer, started looking on my archive articles, if I even find enough content for it. After like 30 minutes, I had full month covered and several other dates. So I said, hey, okay, it should be easy. Yeah. So I basically started since Monday, next day, publishing it. Honestly, the very first few articles were kind of weak. When I come back to them recently, I wouldn't write it that way. But over time, the style improved and more interesting stories started to being shared. But the truth is, I always was kind of very interested in history. Not the old ancient history, but the modern history. So for example, what happened in the 80s or 90s when I was alive already. So, but I was a child, for example, or a teenager. So I didn't really realize what was happening in politics, in the world. Now I'm going back to this, and now I realize what really happened and how it affected our lives. Yeah. Why we as a country are here and not there. What was the reason for that? So this modern history was always part of my interest, and I don't know why, but I have this ability to remember things. It's funny because recently I realized my brain erased most things before I joined 3D printing industry. So I have like a snippets of memories, but if I want to remember exactly what happened, I don't really know. I have to look through the photos or some other things to remember. But everything that happened after 2013, I remember everything, including like a given 3D printer name, when it was released, and what is the build plate. So I remember all of the stuff.
That's pretty deep cut.
Yeah, and obviously I started when I started writing those historic posts. In many cases, I was telling the stories I was part of, because of my, let's call it journalism experience. I was describing those events in my articles in 2014, 15, 16.
Yep.
I remembered a lot of nuances that were beyond the news that I couldn't write about in a given time. Yes. Because as every industry, there were some politics, some relationships.
The company still existed, that kind of stuff.
Yeah. And right now, they failed because they were lousy. And they were lousy because this and that. And what you gonna do? Sue me? Come on.
Yes, exactly. It's more fun now to do the news 10 years later.
Yeah. And listen, there are, again, a lot of stories I heard over the years because people started contacting me and telling me such stories about people especially. So there are few very, very well-known figures in the history of 3D printing that I know tons of amazing stories, but I was asked not to share.
Who's one of those amazing figures who you can share about? Let's dish some gossip here.
Yeah, well, so there is a guy who was running 3D systems and then Nexa, right?
Yeah, there's that.
Yeah.
There's also
so-
Desktop Metal and all those kind of things. So yes, there's.
Well,
there's,
so this is an interesting thing. I never met Rick Fulop in person.
oh really?
Never.
That
never
that
had
is
the
interesting.
maybe I saw him on Formnext in 2017.
Yeah, those would be one of the
because-
places.
But I don't recall it. Like I saw the guy, but I didn't know it's the guy. For example, so never
Yeah.
spoke to him, and obviously I know a lot of stories, but I don't want to write those stories because I couldn't confront it with real person. So I'm very critical of what he did, but I'm not critical about his personality, which I don't know. So everything I write not in personal note, but business wise, which I obviously I'm not big fan of, let's say. Honestly, when they first arrived in the news, it was, I don't remember exactly, 2016 or 17.
About 17.
The first news, 17, yes, the first news came out that there is a company that is called Desktop Metal. They will revolutionize the world of manufacturing, and Google invested into them. Oh, and BMW as well.
Yep.
Okay, so this is, but what they are doing exactly? So it took like a year for them to reveal what they are doing. So when they revealed it, and I saw it on Formnext 2017, that's it.
Binder
Okay.
jet printing?
Yeah. So then I remember seeing this huge long machine that was put flashing lights inside, and I was still trying to understand what this machine really does. It was doing nothing. It was just a machine that was shining with green light. That's the whole technology behind it at that time. But then I realized it's binder jetting, metal binder jetting, and okay, so it's not a new technology. And then a good friend of mine from Poland got very obsessed with Desktop Metal, and he was able to score the distribution deal with them.
Okay.
So he got some demo parts, and I took those demo parts to my hand. I was like, really? That's what you were? No, it's great. It's going to be revolutionary. Come on.
You're a typical 3D printer guy. You're just the print quality's not there, and I've seen this one before.
Yeah. So I was.
You're
come
just
on,
jaded.
So yeah.
The desktop.
Since the early days, I was very skeptical, and even in 2020s when they got this great amount of money, I just knew it that they will waste it anyway.
Yeah, Desktop Metal was always really interesting because when I first ran into them, I thought I had the perception of like, there's something under here that's not quite right. It ain't fitting together. But then I learned more about Rick himself and like his history with Proto Labs. And I'm like, oh no, this is a legitimate team who's built a thing. And also knows how to take something kind of mundane and turn it into a useful service, like with what they did with Proto Labs. We're going to make injection molding actually a service that somebody can access through whatever means you feel like. So there was value in that. The issue I had with it was like when they started doing all the acquisitions. I was like, there's something wrong with the metal printing. They're acquiring too many different companies that are not metal 3D printing stuff. What's wrong with the metal 3D printing? And that always seemed like the main issue that they had of like, yes, the core technology was not getting there quickly enough or getting scalable fast enough. I think they thought they could scale it faster than they ended up being able to. And then they needed to diversify in order to keep, revenue moving and everything else. And then you just get into a death spiral at that point. So I don't think it was ever really ill-intentioned. I think they're probably one of the startup stories that's just like, they were too early, and then the rest of the world moved on.
I mean, I don't consider them like frauds that they want to steal money. No, nothing like that.
No, not at all.
It was like this great irresponsibility for actions they took.
That's fair.
So, okay, I have my own story, but I know a lot of people, I met a lot of people over the years that were developing really nice things, and they were unable to move forward with their solutions, products, because, for example, they were from Poland. And in Poland, Poland is a great place to, to live, but also to make software or game.
Yes.
But on PC or PlayStation. But it is not a great place to develop deep tech technology or manufacturing technology. It's just not the place for that. I understand it after my failed attempt, but there are also many other companies that should be able to be successful, but because of this limitation they won't. And from the other hand, we had this Desktop Metal, but also Shapewaves and Nexa and a lot of other companies that received trains of money.
Mm-hmm.
And it's not that it's nothing bad they didn't deliver, didn't make it. It was this irresponsible way of just burning amounts of cash like nothing. This is like what upsets me.
Okay.
That again, there are a lot of stories I learned over the years about other companies. So some very funny stories how like Envisiontech was run. That we have this idea that this is like very important, crucial company for the development of the whole 3D printing industry, and then someone tells like how it was done inside, and you hear like, come on, really? It's like a first month startup, but they were like established for 20 years, and then you compare it to the fact that the Envisiontech deal was worth like 300 million or more.
Mm-hmm.
I don't remember exactly the name.
I don't remember it either, but it wasn't small.
So, and for this, and it was like, well, they had the money, right?
The market
so
is
spend it.
Yes. Okay, that's fair. At the time, 3D printing was hot. It was a good time.
Yeah, but again, the lack of unreasonable actions that were taken by several companies. I was also writing an article some time ago about the collapse of this big AM service provider. Very short name. I don't remember the name right now. Anyway, they had like dozens of very expensive metal 3D printers.
Oh, Velo?
No, Velo. Let me check for France. They were from Ohio, I think.
Oh,
yeah.
No, I know which one you're talking about. Yeah.
They basically bought a tons of metal printers without having orders covered, I believe, because they got bankrupt in the same year they started, I believe.
Oh, never mind. I'm thinking of a different one then, because the guys I'm thinking of had been around for about 10 years.
Well, it was Zeda.
Oh, no, I don't know these guys. Yeah, that was quick.
Yes. So I'm looking through my
Did they get propped
article.
up during the hype train of 2021 or so?
Yes. So they had 4 Velo 3D printers, 4 ADAP FormUp 3D printers, Arcam EBM printer, 7 high-quality CNC milling machines, including 5-axis models from DMG Mori, tons of additional equipment. I saw the story by by 3dprint.com, where there were photos of the whole facility and all the equipment inside. It was really, really amazing. But I believe it's like in many European countries where companies are given European funds to grow, and they're just spending those monies like crazy, buying some fancy machines, fancy equipment, thinking like, okay, so now we're gonna go to the market and try to find some orders for it. The very same case that it was in 2012, 2013, 14. Hello world, I just bought a 3D printer, now I'm waiting for the orders.
Yes.
So people were buying MakerBot replicators or, I don't know, Ultimakers at that time, and waiting for world to fulfill the printers with jobs.
Yes.
But the initial investment was kind of small. But imagine buying 10 very highly specialized metal 3D printers with the same kind of approach. Like,
yes,
we are ready.
It's build a better mousetrap and the world will beat a path to your door. That's how an engineer thinks. That's how they all land. It's such a common mistake that people shouldn't make it, but it happens all the time. That you'll create the thing and everyone will come. But it is amazing that lesson doesn't stick more. But it's so persistent across all the industries and that kind of stuff. I don't know why it doesn't stick more. It's so fascinating. But anyhow, what do you think right now? Obviously, there's Bamboo. Bamboo is a tremendous executor. What are other companies that you think are executing really well right now or historically that did well and had life go wrong or got acquired or whatever it was?
I must give a lot of credit to Formlabs. Formlabs is the only company that was created on the very early stage of this consumer 3D printing hype. And not only they survived this hype,
they're doing fine,
but they pivoted to become industrial or medical oriented brand. And as far as I'm concerned, they doing well.
Yes.
I don't know if it's very well, enormously well, but well is definitely the right word to describe Formlabs career, you can say.
Yes.
So, and I also met Maxim Lebowski.
Nice.
He's probably one of the smartest guys I ever talked to. We talked about some funny stuff concerning the lawsuit they received from 3D Systems in the early days, because I remember we met on Formnext and it was like anniversary of lawsuit to be given to them, and Max told me some stories. Again, I cannot share how it looked like from their point of view.
Yes.
Yeah, but again, extremely smart person. You just feel the aura of uniqueness when you talk with him. So yeah, Formlabs is a very nice example. As for the other brands, I'm obviously the industrial, it's hard to say. So for example, SLM is doing good, but only because they were acquired by Nikon. So I don't know if you can make this is a good example.
That applies to a whole bunch of technologies.
Unfortunately for the Western world, the Chinese brands are taking over, and you cannot really do anything about it. So in desktop 3D printing, aside of Formlabs, it does not make really sense anymore. I mean, there will always be a reason for having some local companies. So there will always be a reason for Prussia to be in Europe.
Yeah.
So you always have to have an option to buy something from a European market.
Yep.
But doesn't make sense for Ultimaker to be as well. I don't know. For other brands, too crowded. If you have there was a time, it's a real story, there was a time, I believe it was 2015, maybe 16, in Poland, we had 34 companies that were identified as a 3D printer manufacturers. It was crazy.
That's it?
And yes, and there were obviously 2/3 of those companies were very tiny garage companies, but we had at least 7 big brands. We had Zortrax, we had Synterit, we had 3D Gens, Zmorph, Omni 3D, and so on and so on. There is no room for that anymore.
No.
And in the world, in industrial world, again, EOS, SLM, 3D Systems, Stratasys, Renishaw, several other brands, but the Chinese are coming. BLT, Farsoon, they are on the Western market for a decade right now. At least Farsoon is for a decade.
Yes.
And they are growing. E+,
Do you think they will continue to try to move into the industrial sector of it all, or do you think industrial will just change machinery to where it becomes increasingly consumer?
No. They will continue to be industrial.
Okay.
There is very high specialization in China. Again, we're talking about the focus. So for bamboo, they are focused on FFF technology, and that's it. And because they are so successful, look what happened with Anycubic. Anycubic, a company that basically created the home market for resin 3D printers. So there was Formlabs. Formlabs didn't make it. For a brief time, it was British liquid crystal, photocentric and liquid crystal 3D printer, the first printer with LCD screen. And then Anycubic arrived, and everyone started printing on Anycubics at home or offices and whatever. Now Anycubic is shifting towards FFF technology as well. They still make resin printers, but their focus is on FFF technology. Elegu, which started with Elegu Mars printers, again, resin technology. Right now with the Centauri and Centauri carbon printers, they are trying to become a threat against reality and bamboo. So the focus is on the consumer electronic market is on FFF technology. Resin technology is...
Why do you think that is? That transition from resin, away from resin towards FFF? Aside from bamboo's making a lot of money, so everybody's going to copy bamboo.
Basically, that's it.
Okay.
So, because, if you want to scale, you have to go to consumer and office environment. So, resin 3D printer is not good because it's difficult, it's dirty, it's smelly, so it's dangerous, and you have the problem with waste. So there are a lot of issues, and the only advantage beyond FFF technology is surface quality and geometry precision. Okay, how exactly many times you need that?
Yeah.
To justify all the other disadvantages.
Especially in the consumer market.
Yeah. So I would say that all the people that were making figurines already have those printers. Probably they have like 5, 6 at home, garage, or any other place. And that's it. I mean, the longevity of resin printer is pretty high. Only you need to replace LCD screen one at a time and the foil.
In theory, an LCD machine should be better. But yes, the messiness and everything else just messes with them too much.
The companies like, Merit 3D from Utah, they are great in
the large scale
creating large scale manufacturing.
All right.
But those are like exceptions.
Yeah. No, yeah. again, like Merit, well, yeah, those production services again have all the challenges of scale. You get more, sell more parts, but then you get a lower margin for each one of the pieces. So it's just tough to keep it rolling. But alrighty, well, we'll go ahead and stop it right there.